Guys, today we're going to be learning about compound inequalities. Compound inequalities are looking at two inequalities that are joined either by the word and, and they have very different meanings. Okay, so let me write that over here for you guys. Compound inequalities are going to be two inequalities joined by either the word and or the word or. So in example 1, you have, it's called a disjunction when it's joined by the word or. You don't need to know that term, but we're going to solve them separately. So in the first one, I'm going to subtract 7. I have negative 2y is less than or equal to negative 6. And I'm solving, I divide by negative 2. I have y is greater than or equal to 3. And the second one, I solve again separately. So I add y to both sides, and I'm also going to subtract 10 on both sides. So I have 4y is less than negative 6. I divide, y is less than negative 3 over 2. Okay, negative 3 over 2. So this inequality represents my solution set. Y is a number that's greater than or equal to 3, so that's here to the right of 3 or equal to 3, or less than negative 3 over 2. And I only need to see those two numbers on the number line. And you'll notice that the inequality, the graph of it, the shading goes in opposite directions. And the word or is important because you're saying that x or y is a number either in the set on the left or the set on the right that you see. Interval notation is written going from left to right. So if I were to read this from left to right, I would start, I'm going to highlight in blue, I would start here and I would go this way. So negative infinity to negative 3/2, not including negative 3/2, so I put parentheses, or, and then moving, as I highlight in blue, from 3 to infinity. So I'm going left to right, or 3, including 3 this time, so a hard bracket to infinity. And remember, infinity never gets brackets, it always gets parentheses. And so this is the solution set in interval notation. All right, example 2 is the same thing, only now I'm adding in one little thing, and that is that there's a symbol for the word or, and that's the like an uppercase V that you see over here, right here. That's the symbol for or. Okay, I'm going to do the same thing. I'm going to solve them independently, separately from each other. Subtract 8 on both sides. I have m is less than negative 7. Subtract 8 here. I have negative m is less than or equal to negative 7. I have to divide by negative 1. That means I have to flip the inequality symbol. So I have m is less than negative 7, or m is greater than or equal to 7. That's my solution set. On a graph, here's negative 7, m is less than negative 7, or m is greater than or equal to positive 7. Here. Again, interval notation goes from left to right. So negative infinity to negative 7, but not including negative 7, or positive 7, including that all the way to positive infinity. Okay. And then we have the inequalities, the compound inequalities that are represented by the word and. And what these will look like is, in example 3, they will look like all in one inequality. The way we read this is, we read it from the middle. I'm going to use the highlighter. We read that 2x plus, oh, that's not the highlighter. Hold on one second. We read that 2x plus 15 is greater than 3 and less than or equal to 15. So we read it from the middle to the left and then to the right. 2x plus 15 is greater than 3 and less than or equal to 15. So it's both. That's the significance of the word and. All right, the way we solve these is the way we would solve kind of an equation, but it's like you have 3 sections. So we're going to try to isolate x in the middle. We're trying to get this to look like this. We're trying to get it to become x is greater than something and less than or equal to something else with just a number here and a number here. So the way we get to that is we want to first cancel out this plus 15. So what I'm going to do is, let me erase this. What I'm going to do is I'm going to subtract 15, but I'm going to do that 3 times. Once from the middle, once from the left side, and once from the right side. It's like you have 3 sides. And now I start from the middle. 2x is greater than negative 12, and it's less than or equal to 0. Divide by 2. Divide by 2. Divide by 2. Everything gets done 3 times. So now I have x is greater than -6 and less than or equal to 0. Okay, so on a number line, the way that looks is here's -6, here's 0. X is less than or equal to 0, so it's to the left of 0 or equal to it, and it's greater than -6, so and it's to the right of -6. So you have no arrows here. What you have instead is a shading between numbers. So if you're smaller than one number and greater than another number, then you are between those two numbers. And your interval notation will not contain infinity because you're not going infinitely in either direction, to the right or to the left. So your interval notation will just be any number from -6 all the way to 0, including the 0, so hard bracket on the 0. Okay, and we'll do one more. Just like that. Again, these say and. When you see it written this way, it says and. So it reads, again, it reads from the middle. 10 minus 3y is greater than 1 and less than 16. All right, and I'm going to erase that. And I'm going to isolate y in the middle. So I'm going to first subtract the 10 from the middle, from the left, and from the right. This gives me -3y is greater than -9 and less than 16 minus 10 is 6. Now I divide everything by -3. Now the same rules apply. When you divide by a negative, you have to switch your inequality symbol. So this becomes y is less than 3 and greater than -2. So on a number line, here's -2, here's +3. Y is less than 3 and greater than -2. So you're in the middle between those two numbers. Interval notation is from -2 to +3, not including either of those endpoints, so parentheses on both. All right, and you have some examples to do like this for homework. Some are and, some are or, but you'll notice the similarity that the and problems are always shading between numbers, whereas the or examples are always shading in opposite directions on the number line. All right, I'll see you guys tomorrow. Have a good day.